Now, students, it's your linear inequality problem. Linear inequality question is solve the given inequation and graph the solution on the number line. Graph the solution on number line. First, solve the inequality. Inequality is 2y minus 3 is less than y plus 1. This is less than or is equal to 4y plus 7. So first, you should take this part, means 2y minus 3 is less than y plus 1. And next, you should take this part and y plus 1, this is less than or is equal to 4y plus 7. And now it is given that y is a real number. Y is a real number. Transpose this y towards left. So 2y minus y is less than, transpose minus 3 towards right. So 1 plus 3. And now transpose y towards right. So 4y minus y, transpose 7 towards left, 1 minus 7. So 2y minus y becomes y is less than 3 plus 1 is 4, and 1 minus 7 is minus 6 is less than or equal to 4y minus y becomes 3y. So y is less than 4, and now dividing both sides by plus 3. So if you have to divide by a positive quantity, then inequality remains unchanged. So minus 6 by 3 is minus 2. This is greater than or is equal to y. So combined solution of y is, now the combined solution of y is y greater than or is equal to minus 2 and y less than 4. Next, here it is given that y is the real number. Now, represent this inequality, means this region, on a number line. So first you should draw a number line. Let this is 0, minus 1, minus 2, and let this is 1, 2, 3, 4. So y greater than or is equal to minus 2. So y greater than or is equal to minus 2, and here inequality is inequality with equality, means the minimum value of y is minus 2, and minus 2 is excluded because equality is given, and less than 4, so 4 is excluded, and less than 4. So all the real number lies between minus 2, from minus 2 to 4, means greater than or is equal to minus 2. So including minus 2 and excluding 4, and all the real number lies between this region. So it's your graph. Now we are coming the next question. It's a question on the screen. Given that x belongs to real number, solve the following inequality and graph the solution on the number line. 1 minus 1 is less than or is equal to 3 plus 4x, and this is less than 23. Now subtract 3. 3 is the positive quantity, so inequality remains unchanged. Minus 1, minus 3, and 3 plus 4x minus 3, and 23 minus 3. Minus 1 minus 3 is minus 4, is greater than or is equal to 4x, and this is less than 20. Now divide by 4. If you divide with a positive number, then inequality remains unchanged. So minus 4 by 4, 4x by 4, and 20 by 4. This is minus 1 greater than or is equal to x, and this is less than 20 by 4 is 5. And it is given that x is the real number. So the real number from minus 1 to 5. Let this is 0, minus 1, 1, 2, 3, 4, 5. it is given that equality include with a minus 1 means minus 1 is included, minus 1 is included, and is strictly less than 5 means 5 is excluded. So all the real number lies between minus 1 to 5. It's your region, minus 1 to 5. Real number starts from minus 1 and up to 5. It's another question on the screen. P is x, but the condition on x is 2x minus 1 greater than 5 and less than or is equal to 11, and x is a real number. And q is x, but condition on x is 3 plus 4x is greater than or is equal to minus 1 and less than 23, and x is integer. Now represent P and Q on number line and write down the elements of P intersection Q. So first, P is given. P is x such that 2x minus 1 is greater than 5 and this is less than or is equal to 11, and x is real. So 2x minus 1 is greater than 5 and less than or is equal to 11. Now adding 1 in the inequality, add 1, so it becomes 5 plus 1 is 2x minus 1 plus 1 and 11 plus 1. So 2x minus 1 plus 1 becomes 2x is greater than 6, and this is less than or is equal to 11 plus 1 is 12. Now divide by 2 because 2 is positive. If we divide by a positive quantity to the inequality, then inequality remains unchanged. So 6 by 2 is 3 is greater than x is less than or is equal to 6. And here it is given that x is a real number. X is a real number. Now Q is x such that minus 1 less than or is equal to 3 plus 4x, and this is less than 23, and x is integer. X is integer. So 3 plus 4x, this is greater than or is equal to minus 1 and this is less than 23. Now subtract 4, subtract 3, not 4, subtract 3, because first you should remove this 3. So by subtracting 3 to the complete inequality, so minus 1 minus 3 and 3 plus 4x minus 3, this is less than 23 minus 3. Now it becomes 4x minus 4 and this is less than 23 minus 3 becomes 20. Now divide by 4. So minus 4 by 4 is, if you divide by the positive quantity, then inequality remains unchanged. Minus 4 by 4 is minus 1 and this is 4 and this is 5, and here x is integer. So the integral number greater than minus 1 and less than 5, and the real number greater than 3 and less than or is equal to 6. So graph of P, let this is real line, 0, 1, 2, 3, 4, 5, 6, 7 and so on, and real line for Q, number line 0, 1, 2, 3, 4, 5, 6, 7, and now it is minus 1. So the solution of P is x greater than 3 and less than or is equal to 6, and x is a real number. So greater than 3 means excluded 3 and less than or is equal to 6, included 6. It's all the real number. Now for the Q, x greater than or is equal to minus 1 less than 5. So this is minus 1. Equality is put here. So minus 1 included and 5 excluded. but here it is given that x is integer. X is integer means -1 comes in solution, as well as 0, 1, 2, 3, 4. Means q set becomes here, q set becomes -1, 0, 1, 2, 3, and 4. And p set is x greater than 3 and less than or is equal to 6. X such that x greater than 3 and less than or is equal to 6. And x is real. So x is real, greater than 3, less than or is equal to 6. This is P, and Q is -1, 0, 1, 2, 3, 4. It's the solution. Now the common solution, P intersection Q. So the common solution is, here x starts beyond the 3 and less than or is equal to 6. So the integer beyond the 3, greater than 3 and less than or is equal to 6, which also belongs in Q, that is only 4. So it's singleton set. So it's your solution, P intersection Q. It's your new question. Find the solution set of the following inequalities and draw the graph of their solution. Now first is given mod of x plus 5, this is less than 8. Now using formula, mod x is less than a, it implies that where a is positive, x lies between -a to a. So here x plus 5 is greater than -8 and this is less than 8. Now subtract 5. So x greater than -8 minus 5 and this is less than 8 minus 5. 5 subtracting in the inequality, -8 minus 5, x plus 5 minus 5 becomes x, and 8 minus 5 means x is greater than -13 and this is less than 3. And find the solution set. It's your solution set, and draw the graph on their solution sets, of their solution sets. It is not given that x is integer or natural or whole or real. So x should be real. Now draw on the real line, number line. Let this is 0, -1, -2, -3, and so on. Let here this is -13, and let this is 1, 2, 3. So x is strictly greater than -13 means -13 is excluded, and strictly less than 3 means 3 is also excluded, and all the real line lies between -3 to 3. It's your solution graph. Now for the second, mod of x minus 1, mod of x minus 1, this is greater than 3. So using mod x is greater than a, where a is positive, so it implies that x less than -a or x greater than a. So apply this formula. So x minus 1 is less than -3 or x minus 1 is greater than 3. So -1 transpose towards right. So x less than -1 becomes +1. -3 plus 1 is -2. And -1 transpose towards right. -1 becomes +1. 3 plus 1 is 4. And x is a real number. So x is less than -2 and x is greater than 4. Represent on the number line. Let this is 0, -1, -2, -3, and so on. And let this is 1, 2, 3, 4, 5, and so on. So x is less than minus 2, but strictly less than, so minus 2 is excluded, and less than minus 2 belongs to this region, and x is greater than 4, strictly greater than 4, so 4 is excluded, greater than 4, it's the region. It's the graphical solution. Now I am taking the last problem, last question, 5 number. 3 upon mod of x minus 2 is greater than 5. Some students will do here, why we should not transfer to mod of x minus 2 towards right, but it will be completely wrong. So you should have to reciprocalize this, means taking reciprocal on both sides. Here 3 is positive, mod of x minus 2 is also should be positive, and greater than 5, all are positive. Now taking reciprocal, reciprocal. So 3 upon mod of x minus 2 becomes mod of x minus 2 upon 3, and if you have to take reciprocalize this, so inequality becomes changed and it becomes 1 by 5. Now multiplied by 3 both sides, because 3 is positive, so inequality remains unchanged. So mod of x minus 2 is less than 3 upon 5. Now using this formula, mod of x is less than a, so x lies between minus a to a. So it implies that x minus 2 lies between minus a to a, right? So x minus 2 should be eliminated by adding 2 in the inequality, because 2 is the positive, so inequality remains unchanged. If you have to subtract or add in the inequality, the inequality remains unchanged. So by adding 2, minus 3 by 5 plus 2 is less than x, and this is less than 3 by 5 plus 2. So x is greater than 7 by 5, and this is less than 13 by 5. X is greater than 7 by 5, and it is less than 13 by 5. X is greater than 7 by 5 means 1.4, and this is less than 13 by 5 means 2.6. It's the solution set of your fifth part. X is real. X is real. If you want to cross verify it, then take the number x between my 1.4 to 2.6. 1.4 to 2.6. Now let I'm taking a number 1.5. 1.5. So if you put x is 1.5, so 1.5 minus 2, just it's a part of verification. 3 upon 1 minus 5 is 0.5. Is it greater than 5? So 3 upon 0.5 means 6. It is greater than 5. Now let I am taking 2.5. So 3 upon 2.5 minus 2 is also 0.5, and it is also greater than 5, because 3 upon 0.5, 6 is greater than 5. Let I am taking a number which is greater than 2.6. Let I am taking 3. So 3 upon mod of 3 minus 2 is 1. It is greater than 5. No, not satisfies. X is equal to 3. So it's your solution set. Now if you want to represent it on number line, so let this is 0, 1, 2, 3, 4, and so on. Because x is greater than 1.4 and less than 2.6. So let this number is 1.4, greater than 1.4 and less than 2.6. Let this number is 2.6. Here I am representing this point 7 by 5 and less than 2.6. this point by 13 by 5. So all the real number greater than 7 by 5 and less than 3 by 5. It's your solution set. It's your next question. Solve the following inequality and graph their solution set. Two x minus 5 upon x plus 2, this is less than 2. Some students are trying to transpose x plus 2 to right. It will be completely wrong. For this type of question, you cannot transpose the variable part. You cannot transpose the variable part. Let x plus 2 is a constant number, then you have to transpose towards right, because x plus 2 is the variable part, so you cannot transpose it. But 2 is the constant, so 2 you may transpose, 2 you can transpose towards left. So 2x minus 5 by x plus 2 minus 2 is less than 0. Now taking LCM. So x plus 2, 2x minus 5 minus 2 times of x plus 2, this is less than 0. So 2x minus 2x goes to cancel out, and minus 5 minus 4 is minus 9 by x plus 2, this is less than 0. So here numerator by denominator is less than 0, and already numerator is negative, so denominator should be positive, because multiplication of negative and positive is negative. If denominator will negative, then negative negative becomes positive, and inequality goes to wrong, becomes to wrong. But here it is given that numerator is minus 9, so denominator should be positive, necessarily should be positive, because negative into positive is negative. Means it implies that x plus 2 is greater than 0, so x is greater than minus 2. It's your solution set. Now graph of x is greater than minus 2, and here x is real, so let this is 0, minus 1, minus 2, 1, 2, and so on. So x is greater than minus 2, so greater than minus 2 means excluded minus 2 and all the real number greater to minus 2. It's your solution region. Second part, x plus 8 upon x plus 1, this is greater than 1. Now transpose 1 towards left, x plus 8 by x plus 1 minus 1 is greater than 0. Taking LCM, x plus 8 minus x minus 1 divided by x plus 1, this is greater than 0, and x goes to cancel out. 8 minus 1 is 7 by x plus 1, this is greater than 0. Because numerator is positive, 7 is positive, and positive by positive is positive. So x plus 1 is positive. 7 is the positive number, and inequality is positive. This whole number, numerator, whole fraction is positive. If numerator is positive, so denominator must be positive, means x is greater than minus 1. It's your solution, and x is real. Now graph, this is 0, minus 1, minus 2, 1, 2, and so on. And x is greater than minus 1 means strictly greater than, so minus 1 should be excluded, and greater than minus 1. So all the real number, it's your graph.